SSH client.
Is anyone going to be in the Jabber room? We could use a Jabber scribe. All right, good morning. Good morning, this is the DOTS working group and we're going to get started. My name is Roman Danilio and I'm co-chairing with.
Yeah, sure.
So we're going to get started. Thank you to our minute taker. And again, last request, we could desperately use a Jabber scribe to support our remote participants. Desperately use a Jabber scribe. Okay, wow. All right, so just putting up, it's very late in the week, but the note well, of course, applies. I'd ask you to just quickly look at that. And if you have any questions, don't hesitate to ask the chairs or the EDs as to what's going on there. Administratively, the blue sheets have been passed around. We have an agenda. This is largely what was on the mailing list. We're going to talk about primarily about the interop that happened at the hackathon, and then some new work to bring into the working group. Would anyone like to bash this agenda? Okay, so with that, let's proceed forward. To quickly summarize where we stand with all the adopted kind of drafts, we're making fabulous progress on getting things closed. Our requirements document is in IETF last call, and that last call should be wrapping up, I believe, tomorrow. We have a couple of documents already submitted for publication, both the two protocol drafts, the signal draft and the data channel draft. One is with an AD evaluation, and we're bouncing back comments based on what Ben had asked. And after that, I believe Ben is going to review the data channel. The use case is ready. It's actually with me as the shepherd. I need help from some of the authors to make their IPR claims on the list. So I've asked on the list, I've reached out kind of privately, and that's what's blocking moving forward with that use case document. And then with the architecture document, I'd love to hear from the authors because I've gotten a bit of a mixed story as to whether we're ready to go to working group last call or whether we still need another revision based on some NAT issues that were there. So that's where we stand with those drafts. And honestly, kind of with that, we were going to get into the new work. 3 weeks ago on the mailing list, Frank and I asked a question, given that a lot of our charter documents were nearing kind of conclusion, whether there were new thoughts on what the working group wanted to take on. And what you're seeing there, what you're seeing here in this agenda is primarily kind of that. And we do have some time at the end of the session to talk about any other additional ideas we have to charter for the working group. So with that, I'm going to turn the mic over to Kanami, who's going to be telling us how things went at the hackathon. Get your slides.
Yeah, thank you for the introduction, Roman. Oh, yeah, thank you. I'm Kanami Nishizuka from Entity Communications, and this report is from I and John Sharrow from NCC Group and Lian Xia from Huawei. Then we did a hackathon in the last weekend in the IETF 103. Then we did some interrupt testing, and also we did some real DDoS attack scenario Then I'd like to report about the result of the things. Then this is the fourth interoperability testing in the IETF. So actually, the last IETF, IETF 102, we did data channel interrupt testing for the first time. But actually, this time we proceed to the hackathon to show that the DOT protocol functional superiority for the DDoS protection. So we try to handle the DDoS attack in our controlled and testing environment. And also, actually, as Roman said, the draft is now under the is proceeding to the publication. So these testing are conducted in the latest version of signal channel and data channel draft. Then here is the setting of the interrupt testing. Then we set up the internet-facing web servers on the, if it there on the bottom of this figure. Then a narrow link resides in the transits, so it can be easily get congested or saturated by the DDoS attack. Then dot client is in one of the web server, and also the dot servers reside in the upstream networks. Then we used our open source implementation called DOT, and also we used the DDoS Secure's proprietary implementations. Then also we tried the DOT gateway functionalities, and we did the DOT client and DOT servers functions, vice versa. Then after the server get DDoS attacked, the narrow link are saturated. So all of these web servers can be affected by the DDoS attack, because this narrow link is saturated. So no one can go through this link. So all of the servers are damaged. Then the dot client request for the help with the mitigation request over the dot protocol. Actually, the dot protocol communicate over this narrow link. So if the dot protocol cannot work over this narrow link, then it is a problem. But we showed that it can work. So I'll show that result. Then we, as I said, we had two independent implementations. One is a Godot, which source code is open in the GitHub, this link, and it has functionality of dot client and server. Then also it has a protection functionality of insertion of ACL or routes on the some router platforms, and also it has a BGP route injection function, so it can work as a traffic redirection or remotely triggered black holing. Then DDoS Secure's implementation is implemented on their DDoS mitigation system, so it has a more complicated or sophisticated way to protect the servers. Then we both tested the peacetime communication and attack time communication. So we tried to use these signal channel functionalities and data channel functionalities in this hackathon. Then here is the result summary. So above table is a high-level summary of communication in attack time. Actually, in peacetime, those functionality is okay, of course. So we checked if it works under the attack. Then during the attack time, the link is overwhelmed by SYN flood, so over 90% of packet loss was detected for downstream traffic. However, as for the upstream traffic, there is no packet loss, so the communication is kind of one directional in that case. Then mitigation requests only requires the upstream traffic. So actually it worked even in attack time by design. So that is the most significant point of the superiority of DOTS protocol. But however, there are failing functions in attack time. So for example, heartbeat mechanism couldn't work because it lost the schedule from server to client. Also, resumption or renegotiation of DTLS cannot be done. And also, all of the channel communications failed because they use the TCP, so they cannot use they cannot even do the handshake over this congested narrow link. Then from here, I'd like to explain some issues about the one-directional communication situation. So about the deep...
Konami, I think Tura had a question about the last
Okay.
slide.
Yeah.
Just jumped in.
Hey, Konami, nice results. I mean, on the DTLS resumption, I had a quick question. I mean, I understand the problem with DTLS handshake for TLS 1.2 where, but with DTLS 1.3, the DTLS handshake itself could carry the mitigation request. So did you get a chance to try that?
Yeah, that's right. We use the DTLS 1.2, so it cannot be worked in this situation. But yeah, it has not been tested, but I assume that the DTLS 1.3 can work over the narrow congested link.
Yeah. I mean, the advantage is the client hello message itself could carry the mitigation request in case of DTLS 1.3, and that gives a good advantage.
Yep. Yeah, thanks. Yeah, then about the DTLS resumption, yeah, here's the text from signal channel draft 4.7 heartbeat mechanism. Then they use the DTLS resumption in case there is a reaching of missing heartbeat allowed count. However, in this situation, from DOT server, attack the DDoS happen, then copying from client server can be received from DOT server. However, copying response from DOT server to client cannot be seen from DOT client. So DOT client try to resend the copying for the several times before the reaching to the count of missing heartbeat allowed. Then the draft says it should do the DTLS resumption. However, the problem was, okay, DTLS resumption is will be failed in attack time. So it can be happen easily. So as an implementation recommendation, we recommend to try to keep sending the mitigation request over the current dot section established in peacetime.
So excuse me, Konami, I want to make
Yep.
sure that I understand. So some of this is mitigated by using the TLS 1.3. And beyond that, is there anything we need to change in the spec?
Okay, in this situation, we don't need to change the spec because the draft is well written about this situation.
Okay.
However, related to these things, next slide I will explain about what should be done in data material.
I'm getting
Yeah.
ahead of you. Sorry.
Yeah. No problem. Then this is a found issue about the trigger or of disconnection. So this draft says that if the dot server does not receive any traffic from the peer dot client, then the dot server sends a heartbeat request to the dot client. And also they check if the copying work. Then if also again the missing heartbeat allowed threshold was reached, then dot server concludes that the session is disconnected. Okay, but however, dot client can send the copying packet to dot server because uplink stream is not congested. So dot server sees the traffic is coming. So when is the real trigger of the starting of heartbeat from dot server to dot client? So if there is no chance to do that, it leads to the conclusion of this connection. But I think there could be a more better trigger of server-side heartbeat because in the congested situation, still dot server can observe the traffic from dot client. So I think this problem causes the no chance of Deadman trigger in this spec. So that's the point I'd like to point out about the current draft text. Okay. Then about the implementation implication, this is not related to the draft text itself, but this is important to make sure that dot protocol or dot software is robust to incomplete communication situation. So the software, especially for dot client, must not be rely on or nor wait for returning packet in attack time. So, for example, our software stacked with no reply from the dot server in the situation of attack time. So this is just a recommendation or implication. Yep.
Fleming and Andreas, could we just go back to the previous slide? I want
Yep.
to make sure I understand. So the issue that you're calling out here is that the client does not receive the heartbeat from the server. It's not an issue in the reverse direction. Is that correct?
Yeah, dot client cannot receive the
Right.
heartbeat. Yeah.
Okay. So basically in this particular scenario, it's only the client that's concluding that there is no connectivity. The server is fine, right? Because it receives the heartbeat.
Yeah, that's right. But actually, I recommend to continue to use the existing DTLS connection because, as I said, the DTLS resumption could not work. So dot client think, oh, heartbeat is missing. But recommendation is it should keep trying to use the current DTLS session. So copying will continue after the this situation, I think.
Right. Okay, but I mean, I'm just trying to remember the sequence of events that's going to that's going to result from this, right? Because if the server was not receiving the client ping, then the server might conclude that the client is under attack and initiate mitigation and all that. That wouldn't be so good. But in this particular case, when the client does not receive a response from the server, is it just basically the DTLS resumption that's not taking place correctly, or the client is trying that and it really shouldn't, or is there another side effect?
No, sorry, I couldn't get the last point, sorry.
Is it only, as you're showing here, the DTLS resumption, the client essentially is not getting the heartbeat, so it concludes that there is no session and it tries to do DTLS resumption, but that's the only thing that the client is doing in this particular case, right? Or would it also potentially try to contact another server and set up a different session?
I got my, yes, dot client can work as so. So if that case, the case is so, then yeah, dot server can conclude that there is no serial anymore from dot client. Yeah.
Okay.
Okay, and also I thought that if the missing heartbeat allowed count or other session configuration is already agreed on the when the session was established. So after the back off of these copying, also I think a dot server could conclude that okay, they are missing, they are sending several times, copying several times. So I think this timing also dot server could conclude that the something happening on the dot client was.
So we have John and Tiru in line. I think they
Yeah.
also want to respond to you for it.
Okay.
So John,
Okay, so yeah, some clarification that's taking place here, and Tiru may be saying the same thing. So the client is sending his requests or sending his heartbeats out to the server, but is seeing no response. The client at that point in time has the responsibility to continue if he wants to send a put mitigation request or something similar. He can still send it to the server, but he will not get a response back. But he is blindly sending out the put to the server. In parallel, because there may be a restart or something somewhere, he should be trying to restart or set up a new session. So either resume a session or set up a new session to try and talk to the dot server. So the communication, he is just talking blind at that point. From the server's perspective, he is seeing ping requests coming from the client so that he knows that there is a degree of connectivity. But when the server sends his own individual ping requests back to the client, he does not get a response. So from the server's perspective, he realizes that the client is in a quasi-cripple state, that there is data communication problems, at which point the server still thinks the client's alive because he is seeing his ping requests coming in. And then at that point, if there's any trigger mitigation falses set on any mitigation requests, he will then invoke those mitigation requests at that point. Does that help in clarification there?
It does. I'm just trying to think through, you know, what are the incorrect ramifications of what's being described here? And it sounds like the one that's incorrect is the client concluding that he should try to initiate a new DTLS session, whether that's to the same dot server or a different one, because most likely that's not going to succeed, right? Everything else still has the intended results, if I understand correctly.
Okay, so the specification specifically says that the client should continue using the existing channel whenever he's doing any requests. In addition, he should be requesting or trying to set up a new session, but not, the spec doesn't talk anything about to an alternative server at this point. The client needs to start a new session just in case the server has restarted, let's say been rebooted or whatever, and therefore the existing session keys no longer work. So he needs to start trying establishing a new dot session with a new set of keys or trying to resume or whatever back to the server, just in case it's just a case of the server just been rebooted. So
Right.
at that point, the client is doing two things. The client, according to the spec, is not going to go and try an alternative server. He is going to continue using the existing channel on the assumption that it's a one-way loss, but he will start a new session or try to start a new session in case it's the server has just been restarted.
Right, and I guess the recommendation that Konami is showing here, that would essentially address the issue. So I understand. Thank you.
Thank you, John.
all right, thanks, John. And Tiru, you wanted to also comment on that?
Yeah, I think John pretty much clarified it, so I have nothing to add. Yeah, thanks.
Right on,
Thanks, John.
thanks.
Okay, this is just, okay.
Actually, before you get, so as regards to that issue, you've identified, you know, how this is performing in, you know, in real world kind of modeling, but we don't believe we need to change the spec is the bottom line.
Yeah, no, the bottom line, we don't need to change that. Then for more flexible protection, this is could be a suggestion. So I'd like to talk about these things if it is applicable. Then it is assumed that data channel filtering rules cannot be installed or removed in attack time. But I just thought, what if a dot client need to change the active mitigation filters in attack time, because in attack time, those client could feel that inconvenience about the triggered filters. So what can be done from those client in the attack time about these data channel filters? So I thought that as a point one, should we add a control of data channel filtering rules via signal channel by kind of name of AGEs or something. Then the second point, should we add some interface to get the status of data channel filtering rules via signal channel? But it could maybe, as for the second point, it could be lost because there is only one directional communication. But I thought these points could help the situation from more flexible protection control.
Fleming, Andreas, yeah, I was just thinking the same thing. I mean, the first option that you're showing here, I could see that making sense because that would only require essentially upstream communication. But the second one, I mean, if that's going to work, then why wouldn't it work over the data channel would be my question.
Yeah, that's right. Yeah.
Chair?
Hey, Kanami, Thiru here. So I guess I like the first option. I mean, adding the control of data channel. I think it's pretty much looks like it's going to be required, especially for the whitelisting ACLs that's going to be created, because the DDoS attack traffic could be emerging from the whitelisted IP addresses of prefixes, and signal channel could be used to override that. So option one seems to be like a good option. Maybe you should propose a draft and explain the problem, and then we can take it forward.
Okay, that's good. Yep.
So, Chair, I just want to make sure I understood what you were proposing. You were endorsing option one. I heard Fleming also talking about option one. But to do that, we have two options, of course. The draft, the signal channel draft itself is now kind of with Ben. So our ability to modify something substantial, this, that'll take some working. And then there's discussion of, you were saying, Thiru, to create another draft that would patch effectively the signal channel.
Yeah, I mean, signal channel is pretty much extendable, and I mean, we need to discuss this problem statement further. I mean, there seems to be some usefulness in it, but I would like to discuss more on the situations where the whitelist needs to be overridden and why that needs to happen, and
Got it.
we can start from there.
Understood.
Ben Kadek. So, I mean, we don't need to consider the signal channel finished. We can put more stuff into it, and that's not a problem. It would only be a question of, if we thought this new stuff was going to take like 6 months to finalize or something, and we don't need to hold up the signal channel for that sort of thing. But if we have a good idea what we want to do, we can just do it.
Okay, makes sense?
Yep.
Okay, so more discussion on option one. We should
Yep.
take that to the list,
Yep.
flesh that out, and figure out how to proceed with
Yep.
with making the
Yep.
change
Yep.
or
Yep.
deferring that.
Okay. That's good. I got that. Okay, so this is the wrap up of this presentation. So the takeaways, we confirm that the functional superiority of those protocols for this protection. So actually, mitigation requests of a signal channel can work even in attack time by design. But as I said, there are functions do not work under the attack. But the draft is not needed to be changed. But as for the installation of, controlling of the data channel, yeah, as Roma said, we will talk a lot more about those things on the mailing list. Okay. Also, the implication for the implementers or developers, then the consideration about the incomplete communication in attack time should be carefully taken. So, yeah, that's my suggestion. Okay, this is the end of my presentation. Thank you.
Okay, we have two on the.
John, please.
Yeah, okay, just I want to clarify back with TLS 1.3 and so on. TLS 1.3 we were not using as part of this process. TLS 1.3 is out, but we actually were using TLS 1.2 over the data channel. We have not been using DTLS 1.3 as that spec is not yet out, and I don't have support for testing that out as we speak at this point in time. So everything was done with either TLS 1.2 or DTLS 1.2.
Yep, me too. Our implementation is also the same status.
Thanks for that clarification.
That was it, thank you.
Ben Kadek, DTLS 1.3 is in working group last call.
So it's close. Okay, other comments? So the chairs would like to again profoundly thank Konami, as NTT, John at NCC Group, and kind of Huawei for doing these last 4 interops. We have gotten a tremendous amount of fabulous feedback. We would not be where we are with the drafts if the team and you have not been doing all of this at these last kind of 4 meetings, bringing that back to the working group and us changing that. So we profoundly appreciate it. And thanks so much for all your hard work.
Yeah, thank you very much.
Okay, so next so that brings us to discussing the server discovery draft. And to set the stage for this, we initially brought this up a number of months ago, but decided to defer conversation on this until we got the core drafts done. And now that we are at the point that we're talking about kind of publishing those, we're bringing those drafts back to talk about what we want to do with them. So again, these are still individual submissions. So Chiru, I'm going to bring the slides up. Are you going to be ready to go?
Till, you can do the presentation. Are you there?
Chiru, we were going to do the server discovery drafts. All right, so why don't we figure out those comms, and we're going to switch a little bit. Unfortunately, because of remote participation, Chiru actually has the next 3 items. Med was not able to join us, so we're going to jump to the last of the documents. Yuhi, we're going to talk about a new use case about DDoS mitigation offloading.
Thank you for giving me presentation slot. Okay. I'm Yuhei Hayashi from NTT. I'd like to explain our new ID. This is a summary slide. We wrote down an idea about the DDoS mitigation fraud use case and a signal channel expansion based on our report at IETF 102. And we extended a YAM module of signal channel so that dots can send attack information such as top talker. In IETF 102, I made a presentation about DDoS mitigation overall use case using Go dots in a single domain network. So we use Go dots as interface between flow collector and orchestrator and DDoS mitigation system and orchestrator. The main point of the POC is P router in core network filters attack traffic based on the detection information of DDoS mitigation system. In addition, we introduced our requirement So we want DOTS client to send attacker information, such as top token, to block attack traffic at P router more correctly. These are feedback from DOTS working group. One feedback is that the signal channel should be frozen at a certain point. On the other hand, DOTS working group can do some extensions after the crossings are done. Our impression is that signal channel's working state is submit to ISG. So it's good time to discuss some extension of signal channel in working group. And some people say, please write a draft. So we will written a new idea about the extension. This is my first idea. This is a component diagram of mitigation flow use case. Left one is a component diagram of in our draft. Right one is a use case, component diagram in use case. So the difference, 2 point. DMS have a client function, and router switches collaborate. This is a sequence diagram in our draft. The main point of our proposal is that, so this point, DDoS mitigation system sends request to orchestrator using DOTS, and orchestrator configure the router using such like a BGP flow spec and so on, so that a router block attack traffic based on detection mitigation of DMS. To block attack traffic at P router correctly, we expand YAN signal channel module so that client can send attacker information. To expand conventional signal channel, we use argument statement of YAN language. This slide shows that contents of attacker information. It is difficult to send all attacker information, so we expand it so that DOTS can send top talker. Some people gave me feedback to this draft, so I will revise the draft for IETF 104. If you have more feedback, please give me a comment to mailing list. My presentation is that's all. Do you have any question?
Hi, can you back up 2 slides for the time series? One more. Yeah. Could you, oh, Roman Donadio, CMU. Could you kind of back up, just kind of start from the top and walk telemetry monitoring system to orchestration, the network admin to orchestration, and kind of talk through that flow a little bit? It's some of the things I asked on the mailing list.
Yeah. So I think I want to choice by network's policy, and so I will revise this part to network can select from triggered by a monitoring system or network administrator.
So can you describe the workflow then that gets the network administrator talking to the orchestrator?
Here?
It's the second line?
This one?
Right. So I get how a telemetry system, sees something and it says, hey, I need to do something about that, and it talks to an orchestrator. I don't understand now the network administrator is triggering something with an orchestrator because someone needed to tell the network administrators to do something.
So this component is in a single domain network. So network administrator watch the monitoring system and notice DDoS is occurred in a network. So network administrator use dots to redirect suspicious traffic from one network to Scrubby Center. This.
Got it. So it's the telemetry system saw something and automatically said, orchestrator, I saw something. The network administrator also was watching a console, something and said, wow, that looks odd. I'm going to tip the orchestration system. So they independently observed the same phenomena. Because I asked because in the draft, it looked like there was this workflow thing where the telemetry system talked to the orchestrator was waiting for some network administrator to take action, and that triggered another request. And that was my confusion.
So far, my draft is unclear. So I revised my draft.
Okay. Yeah, thanks. If you could provide some clarity, that would be helpful.
Yeah.
Appreciate it.
Okay, and Thiru on the line, and he has some question. Okay, Thiru, you can.
Hey, I have a quick question on the DDoS mitigation system talking to the orchestrator using dots. I mean, I was just wondering why can't the DDoS mitigation systems just use any of the northbound interfaces? Like it could be an SDN controller, and you could just program that to program the network devices using BGP flow spec, right? I mean, why do you really need dots here, and why can't it be done using any of the existing control message configuration that's already there?
Sorry, I can't understand your question. So please.
Okay, my question was for the DDoS mitigation system where it's sending the mitigation request in the rectangle you had highlighted. I was wondering any specific reason for using dots? Why can't you use any SDN northbound interfaces to program the orchestrator? Why can't the DDoS mitigation system use SDN APIs to basically program the orchestrator to basically install BGP flow spec rules on the routers and switches? What was the need for using dots and not the existing configuration management configuration interfaces?
So my opinion is the reason DMS sends the mitigation request to orchestrator by using dots is that so network administrator maybe want to know orchestrator have to have the status of all status of DDoS mitigation counter status. So I use dots protocol from DMS to orchestrator. Sorry, my reply answer is poor. So I want to discuss in mailing list.
Sure, no problem. Thanks.
Yep, I'm on the mic. Kaname Shizuka from IETF Communications. So I've read the draft, and also the point is the reason why there are two dot communications is that the hash is thinking about the kind of tiered mitigation services. Like for the small amount of attack traffic, they want to use the kind of DMS, DDoS mitigation system, but which could be more expensive. So they try to use the more inexpensive way, kind of filtering on the routers and switches. Then so they want to grow up the mitigation protection countermeasure in kind of the orchestration way. So that's correct.
Yeah, that's correct.
Okay. Yeah, thank you. Then I have the another question. So about the source IP address information, then how many numbers of source IP address can be included in the signal channel? So what is your estimation about that?
So far, I think 10 or 10 source IP address should be included the draft, but
Okay.
I don't concrete idea.
Okay.
Yeah.
Okay. Let me repeat that. 10, so not 10 source IP address, not 10 IP source prefix, right?
Yes.
Yep. Okay. Thank you.
Fleming and Dresden, could we go back to the previous slide again? Sorry, one more. The workflow. Yeah, that one. That was one too many. The one that Roman was asking about previously as well.
This one?
That one, yeah.
Okay.
I'm trying to understand whether this really fits into what we're trying to do with the signal channel. And I guess I have two questions. The first one is, I mean, the value of having a standardized protocol typically is when we assume that there is a multitude of, in this particular case, different clients and servers that want to support the implementation because there's a lot of them, right? I guess my first question would be, do we see that as being the case here between DDoS mitigation systems and orchestrators? Is it worthwhile actually standardizing this? My second question, which is more technical in nature, is the signal channel is designed to operate in an environment that is under attack, right? Specifically because the link that we're trying to signal over is very congested. And there's a lot of compromises, if you will, that the signal channel has as a result of that, right? It's UDP based, right? There's not necessarily any acknowledgements. As a result of that, there's limits to how much information we can actually convey. I would assume that not to be the case between the DDoS mitigation system and the orchestrator. So why use the signaling channel for that? Did you understand my question, or you want me to rephrase it?
Yeah, I understand. So your question is why we use the signal channel, not data channel? No.
Or some other mechanism, for that matter. But yeah, let's just say, why signal channel, not data channel, if you want to stay in dots. But, why do you want to use essentially an unreliable protocol that can't convey a whole lot of information and that's designed to operate really in a different environment, I would argue, than I would expect to find between the DDoS mitigation system and the orchestrator?
Okay, so sorry, I don't have concrete answer. So
Okay, that's
yeah,
fine.
I consider and well, I will send that to mailing list.
Okay, thank
So,
you.
John, you're next.
Okay, yeah, thank you. I'd just looking at the summary of the draft. If it was network administrator, then telemetry monitoring systems, then DMS, then orchestrator, then routers, I can get some more of an idea, understanding where this is coming from. In a sense, you could have on your local premises a DMS system that is smart and intelligent. The orchestrator is somewhere within the ISP cloud, and the routers and the switches are somewhere within the ISP cloud. The DMS system can handle all the low volume type attacks. But when the DMS system says, I'm having too much trouble because the pipe is having trouble here, he can then send a DOTS session request up to the orchestrator for the orchestrator then to mitigate upstream what's taking place. Does that help at all?
So is John's characterization of the architecture, is that how you're envisioning it with the deployment of the orchestrator? Well, right. I'm paraphrasing here, John. Maybe correct me when I got it wrong. There's a kind of a question in what administrative domain and which pieces are in the enterprise, which are in another administrative domain. So I think John was saying perhaps some of those mitigation systems and router switches are in an ISP, but the orchestrator and those early telemetry systems are in an enterprise.
I was half turning it around another way in that the orchestrator would be the upstream of the bad pipe,
Right.
and the DMS would be the downstream of the bad pipe.
Okay. So perhaps we should take this one to the list then, if that's okay.
Sure.
Sorry, I will answer in mailing list.
We have we must cut the line, and we have the last speaker, Tiru. You can propose your comments, and then we will go to next.
The gentleman at the mic is next.
Oh, okay, sorry. You can first, okay.
Hey, Maarten Aartsen, NCSCNL. So I'm interested by the part of the draft where the DOTS client is able to signal some of its observations. And I'll pass on this idea to some people in the Netherlands because it might be interesting for their particular use cases, whereas they're not currently DOTS users, but I just wanted to voice that bit.
Thank you. Really helpful. Thanks. Thierry, you have the last word. Oh, sorry. Thierry, the floor is yours.
Okay, I think we can, because this is a relatively new draft, and there are still some space, some improving place. So please just improve it, and we can have more discussion on the main list. Okay.
Okay. Thank you.
Okay. Thank you.
Thank you. Okay, sorry, Thierry, we cut you off there. Can we pivot? Thierry, are you ready to present the server discovery materials?
Yes. Can you hear me?
I do. Let me get your slides up if you give me a minute.
Sure.
So I have the slides up that read server discovery slide 1.
Yeah. Thanks, Roman. Dot server, can you hear me?
We can.
Okay, great. Dot server discovery, this draft was presented in the IETF a couple of times, and there was some discussion on this draft, but unfortunately we couldn't progress this draft much because of the other core specifications. Next slide, please. So today, what we have in DOTS is we are assuming the DOTS client needs to learn the IP address reachability information of the DOTS servers, and we are assuming it's going to be done using some manual configuration, and similarly even for the DOTS gateway. But the whole problem is the DOTS architecture and DOTS signal channels do not specify any specific mechanism of how such information will be learned by the DOTS client. So this draft is trying to fill that void. Next slide. Okay. So what we have done in this draft is we have specified 4 different mechanisms for discovering the DOT server. One is basically the explicit configuration, either it could be a local or manual configuration where the DOTS client is programmed either using either by the network administrator or through some SDN mechanism to basically learn the DOT server IP address and domain names. The other one that this draft discusses is automatic configuration that could probably be done using DHCP. The other mechanisms that this draft covers is service resolution using SNAPTR. NAPTR has an advantage where the DOTS server domain administrator can basically give a precedence for the transports. It has preference. For example, it can say, hey, I want to pick TCP or UDP or UDP or TCP, though the dot signal channel says UDP has higher precedence or UDP. It can also specify ports for which the DOT server is using for listening to connections from the DOTS client. DNS service discovery, basically we are covering 2 mechanisms, either DNS service discovery or multicast DNS to discover the DOTS gateway or DOTS server located in the site itself. And the last and least preferred one is Anycast. So the draft currently recommends all the 4 mechanisms, and and the guidelines is the order in which it's specified is the order in which it should start discovering the dot servers. I mean, this is pretty much a similar mechanism we had proposed, and it's being used for ton server discovery by WebRTC. So we wanted more feedback on the existing on the current discovery mechanisms we have proposed, and if the working group has any feedback on adding more discovery mechanisms or removing any of them which does not make sense for dots. So more feedback is appreciated for this draft, and we would like to take this draft forward. Any questions on this draft?
No questions at the mic.
Okay.
So this is your last slide on this draft?
Yes.
Got it. So Frank is coming up to the mic. Sure.
Sure.
Hi, Drew. It's Frank Xia. I have, I know this is a previous draft that proposed some time ago, and I can see this in this draft currently. You have several ways to do the server discovery, and it seems that you extend some existing protocols. You have some detailed specification of how to achieve the server discovery by DNS-SD or by DHCP extension. So, am I understanding right?
Yes,
you have
your understanding is right.
some very specific extension for protocol, right?
Yeah, the only extension is for DHCP REST role, or pretty much like for SNAPTR, you need to go to INA and register new application tags and service tags. So those are the standard extensions that are required for some of them. Like the instance
Okay.
name needs to be registered. So those are some of the extensions that are required, but they're going to be relying on existing protocols.
So for the other protocol, they are just some guidance or some rules how to use the existing protocol to do the server discovery,
Yeah.
right?
Yes.
Okay. Okay. So if you have talked about if you have included some very specific protocol extension, I think for this part we should be careful. And I personally think that maybe we can have more discussion on the details.
Sure.
So relative to this draft, could the chairs get a sense in the room of how many folks have read either the newest or frankly any version of this draft? So if you've read it, can we see some hands? Okay. So we saw two people, one person kind of read the draft. So two people read the draft for your benefit, kind of two. So I think it's a little hard to figure out what to do here. Who would be interested in helping us review this draft? And I look to the folks that have done implementations. Does this taste like something you'd be interested in working on from the little you've heard? Okay, so we have no one coming up to the mic to talk. So I think, Tiru, for this draft, I know we picked it up before. We deferred it. I think we need to take it to the list. Sure. To talk a little bit more. I see Fleming coming up to the mic now.
Yeah, just a comment. I mean, so I haven't read the latest version. I'm not, one of the guys implementing either. I do think, the overall problem space makes sense, right? We do need to solve this. So I'll just make that comment.
Roman Danilo, CMU, individual, no hat. I echo Fleming's kind of thinking. I think we need part of this to help provision folks using dots. So I would support this work moving forward. Okay, so we're going to take this to the list to talk about a little more. And to stay where you are because you have the next presentation. You're going to talk about multi-homing considerations now. Yeah. So I'm on slide 4.
Okay.
Floor's yours.
Yeah, the multi-homing considerations for dots. The dots architecture and the dots use case briefly talk about multi-homing, but does not go into many details. So this draft goes into details discussing multi-homing considerations for dots. Next slide, please. So some of the objectives of this draft is this draft does not propose any dot signal or data channel extensions. It's just trying to complete the base dots architecture with multi-homing specifics. Basically, it's trying to address dots deployments in multi-homing or multi-interface scenarios where there are multiple upstream service providers offering DDoS mitigation service. It does not recommend any deployment model, but it just talks about various scenarios where there could be multi-homing and how in those multi-homing the dots client could efficiently reach the right dot server for mitigation. And it also gives guidelines on where any cast makes sense, where any cast does not make sense, and how does the dots client handle multi-homing scenarios, and how does the dots gateway handle the multi-homing scenarios. So it covers into various aspects in case if there is a gateway and or if there is not a gateway in between the dots client and the dot server. Next slide, please. Next slide, please.
We're projecting slide 6 now.
Okay, it's taking some time here. Yeah. Okay. The goal of this draft is to basically make sure, for example, if the dots client is provisioned with provider dependent addresses, then the whole idea is to make sure the dots mitigation request is not sent to any arbitrary dot server, because that won't help mitigating the DDoS attack, because the IP addresses are provider specific. And even for a dots gateway, blindly forking all the dots mitigation requests to all the available dot servers is not going to work, because the dot server which cannot serve those IP addresses or prefixes will reject the DDoS mitigation request. And sequentially trying them will eventually delay the mitigation plan to kick in. So this draft is basically going into guidelines, just like IPv6 RFCs refer to algorithms to basically select the right source prefix and destination address for especially provider dependent addresses. So this draft goes into those details, giving guidelines for dots client and gateway implementations. Next slide.
We're projecting slide 7.
Yeah, thanks. So the dots use case draft is already is referencing this draft for multi-homing considerations. This draft is discussing various scenarios where there are single versus multiple upstream providers, and the same provider giving both fixed and cellular connectivity. It also discusses use cases with regard to what happens when the dots client domain is provisioned with provider independent or provider dependent addresses, and the behavior for dots clients and gateways in each of those cases. Next slide. Yeah, we need more feedback on this draft. I don't think this draft got a lot of traction in the working group, and we are hoping that we would like to see more discussion on this, and this should basically help operational deployments for dots, especially in multi-homing scenarios. And we would like more feedback, and if the working group is interested, we would like to adapt this draft.
So as a reminder to the working group on the history here, we had a lot of text in the use case document. We had a little bit in the requirements document. We decided, boy, there was a lot to say about multi-homing. Let's keep those other informational documents kind of simple. And this will allow us to say even more about these kinds of environments. And the origin, we pulled all that text out, and that's the draft we're talking about here. So could the chairs get a sense of who has read this draft in any of its versions? Okay, so we see a couple of hands on that. I think again, as you said, as in this case as well, we have to take it to the list and and get additional feedback. But again, this is as you noted, this is a reference in what some of the informationals we're trying to publish. So thank you for the update.
Yeah.
Okay,
Thanks.
so we have the blue sheets getting passed around again. For those that came in, please do sign up so we can appropriately provision next time. So the third presentation for you, Tiru, is you're going to introduce us another use case.
Yeah,
And
this is
the floor
another
is
use case. Yeah, thanks, Roman. So this is another use case and an extension to the dot signal channel protocol. So it's called dot signal channel call home. So next slide, please.
I'm on slide 2.
Yeah. So the agenda for this draft is to go over the use case and the problem statement, and to discuss the solution overview and the proposed dot signal channel extensions that we're proposing, and to discuss some of the questions that we had, and to hear from the working group on the comments they have on this working group on this draft. Next slide. So, I mean, nowadays, endpoints, especially IoT devices in home networks, are susceptible to be compromised, and they are typically used nowadays for launching DDoS attacks on public servers, and we have seen many such examples in the last few years. This problem could also be applicable to networks like Soho offices. So what we're trying to do in this draft is to figure out a way where endpoints or IoT devices in networks are launching DDoS attacks, and the service provider may have DDoS detection capability, and how these two networks can coordinate and mitigate the DDoS attack efficiently. The other interesting thing is network devices nowadays in home networks are offering security functions, especially for IoT device security and for parental control. Some of the various vendors, I mean, they are offering either this security service either on a standalone gateway or on a home router. On home routers, especially on the home routers that I've been working on, both from Intel and Broadcom, they have FastPath enabled to basically boost the throughput. And the problem that we see is not all the packets get punted to the kernel. So we don't get, if you're using NetFilter or any other hooks to basically take the packets to user space for inspection, we only get specific number of packets, and we basically have to program the packet processor to punt more packets. So by default, we only get specific number of packets, probably 15 to 30 packets that you program the packet processor to punt. So this leaves us open to various attacks where the home routers with even the firewall or security functionality or DDoS detection capability cannot look into all the packets in a flow, and that causes a problem that if the attack traffic is sent to the target after the flow is switched to fastpath, the security service on the home router cannot detect the bad packets and block them. And further, home routers have limited CPU and memory, and they may not be able to detect new emerging or multi-vector or sophisticated attacks. So this is some of the challenges that at least I am facing with regard to some of the DDoS detection capabilities we are trying to build on a home router. Next slide, please. Yeah, and many of the ISPs nowadays are enabling DDoS, outgoing DDoS detection, and I think that's pretty much recommended by many of the DDoS mitigation providers. But the problem they face is they cannot identify the actual device which is launching this DDoS attack, because most of these devices are going to be behind NAT. And with this, the problem is ISPs, unlike the home router, cannot quarantine or isolate the infected device, and the heuristic techniques used by the DDoS detection engine may not be deterministic, and since the home administrator is not involved to give a consent whether the deemed attack flow is indeed an attack flow or a legitimate flow, ISP would end up basically blocking a flow which is classified as attack traffic, but it could be a legitimate flow, and that would cause a bad user experience. This problem is not just specific for IPv4. I mean, we have seen cases where even IPv6 devices can pretty much easily change their IPv6 addresses, for example, using stateless auto address configuration, or they try to even use an IP address not designed by the DSP server. And ISPs may not be able to identify and isolate such IPv6 devices because they are located multiple hops away from the home router. Uh, Next slide, please. So what we're trying to do here is basically fill in the gap basically by making the cooperation between the security service on the home router and the ISP, which is having DDoS detection and mitigation capabilities. So unlike a typical client-server communication where the client establishes a DTLS session or a TCP session with the server, here the DTLS connection will be initiated by the dot server. This is very similar to RESTconf or NetConf call home functionality, where the server is typically located behind NAT or firewall, and so in order to reach it, the server itself initially initiates the TCP connection or DTLS connection to the uh, is initiated by the server itself. And whenever attack traffic from compromised devices from the home network is launched, and the DDoS detection in the ISP detects that there is an attack, the mitigation request conveys the attack traffic information. This is where we did enhancements to the dot signal channel to convey some of the attack traffic information. So using that attack traffic information, the dot server can basically identify the compromised device and take appropriate mitigation action. Next slide, please. So this is one of the prototypes that we implemented on an OpenWRT router. So where we had basically embedded dot server on a OpenWRT router, and then what happens is initially the dot signal channel is initiated by the dot server, and it establishes a DTLS session with the dots client. TCP, if it's TCP transport, then TCP connection will be initiated by the dot server in this case. And after that, whenever the DDoS attack is detected by the ISP, then it would send the DDoS attack details, and the home router basically, for example, if it's located behind NAT, it does a pre-NAT lookup to identify the compromised device and can either block traffic attack traffic from this device to the compromised device, or can isolate the device. Um, Next slide, please. So the call home functionality basically, as I was previously saying, enables the dot server located behind NAT to be reachable by only the intended dot client, and it also probably helps solve some of the DDoS attacks because it's not exposing any IP address to be reachable by the public by the internet available to anybody in the internet. Uh, Once the attack traffic information comes from the dot server, it uses that information to identify the device and take appropriate mitigation actions. For example, if NAT is on path, then the home router uses the attack traffic flow information to find the internal source IP address of the compromised device. On At least on Intel, what we tried was, once we knew what the device was, we punted all the traffic from the compromised device to the target to slow path, and we could successfully detect and block any L7 attacks that were happening on the DDoS attack flows. So that gave us a good uh, uh, leverage to conditionally punt the traffic and to only inspect specific flows from compromised devices, all the packets from the compromised devices. Uh, Next slide, please. Yeah, for the call home, even RESTconf and NetConf have asked for a new port. So similarly, I guess we need to ask IANA for a new port to accept DTLS connections for call home. Some of the extensions that we added to the mitigation request are the list of attacker prefixes and the list of port numbers. This is going to help us do the pre-NAT lookup. And if it's not UDP TCP, then the list of ICMP types which are used for attacking the victim. Next slide, please. So in this case, since the target URI, target FQDN, and alias do not make sense, the target prefix and source prefix became mandatory attributes. And in some deployments, especially, we see that the dot server domain administrator consent may be required to block the traffic from the compromised device to the attack target, especially for false positives. So we also added a new request rejected conflict clause code to indicate back to the dots client that the attack traffic has been classified as legitimate traffic. Next slide, please. We had various questions on this draft. In case if the home router is not capable of detecting new emerging sophisticated attacks, then would signaling attack name, type, or any other ID for diagnostics, would that be helpful? It looks helpful for at least identifying why the home router could not detect specific attacks. Response already has a call home defined in RFC 8071, but we are not sure if there is any real use case for adding dots data channel call home service. So we wanted to ask the working group if they have any specific use cases where they see the need for dots data channel call home. And we need more comments and suggestions for this draft to make progress. So welcome any feedback on this draft.
Any comments? Roman, okay.
Wei Pan from Huawei. If one can you go back to the net slider?
Which one?
Go back. Next. Next one. Yeah, this one. If a net equipment is on path and the home routers are all behind the net, so the home routers can be allocated to the net public address by the net equipment in a random way, and so those clients in this scenario how to can't find the correct those server to send the mediation request. I think this is a big problem here.
I didn't get the problem. Sorry. Could you please just repeat that?
What? I mean, in when the net equipment is on path, the home routers, the traffic is public address. The external source IP addresses can be allocated by the net equipment in a random way, and those client can know which home router or which dot server have the have the scope of IP address, source IP address. So I think those clients.
Yeah, so here the ISP is the one which is going to be assigning prefixes or IP addresses to the dots to the home networks. So the ISP should be pretty much aware of from which home network the attack traffic is coming, right? Even if it's located behind NAT. So if you see a mobile network, they have PCRF and other ones where they do the NAT logging, and they know pretty much which router is generating what amount of traffic, and whether they are indeed generating any attack traffic. So this is even if it's behind NAT, the ISPs know which home is generating what traffic today.
Roman Dinelio, Carnegie Mellon, no hat on. I generally like this use case. One thing I wanted to say practically, though, since we're now talking about the ISP touching something in a home network environment and making things happen on that home network behind it, just include some language in the privacy section to talk about what's not getting leaked to the ISP.
Sure.
Yeah, Kanami Nishizuka from NTT Communications. Basically, I like this draft, so I want to support it. Then, there may be a discussion about the not in IPv4 case, but the internet traffic is moving to IPv6. So also, this is also useful for IPv6 cases. Then about the open questions, you said does dot client also need to convey attack name type or identify diagnostics? Then I think also, the home router may not be capable of detecting new margin sophisticated attacks. And also, I think the home router may not be capable of blocking or distinguishing the new margin sophisticated attacks. So I don't think such kind of new information is required because such kind of limited function of home router cannot do anything on such kind of new, even if those new informations are given.
Yeah, agreed, Karami. I mean, it's just for diagnostic purpose. For example, the security vendor can go back and update the signatures basically and learn that hey, there's new attack vector and it does not have the capability. So it's not going to be immediately useful, but it's going to be used for basically identifying why the home router did not detect those attacks. Basically.
Yeah, for
It's just for
diagnosis.
diagnostic
Okay.
purposes. Yeah, it's just to know that hey, your limited DDoS detection capability is basically obsolete and you need to upgrade, right? So those kind of diagnostic information basically.
Yeah, got it. Thank you.
Hi, Frank Xia, Huawei. Comments as an individual. I personally think, yes, this is a valid use case, and but from the implementation view, from my personal view, if we want to achieve this goal, so it means that the home network gateway should support the DOS server function, should support the DOS protocol. But I'm not sure that, it's a very limited device in every home. So it's different from our previous design because previously for our DOS protocol, usually is client is located on the DOS client is located on the CPE devices for the web server or for the web server side or the enterprise side. And the server is usually some ISP or some cloud service controller or something. But now your DOS server is on the home network gateway. So I have some confusion about it. Maybe so this by looking at your use case, I also think about actually essentially this the solution reflects the idea is that we need to do some near source attack mitigation. Actually, I think that's a key point of the solution of this draft. So the similar case can be, we have some other similar cases. For example, for the data center or for the branch network, they have the outbound attack to the network. So I think the solution you proposed here can also be used by those use cases. So I think maybe later you can add more use cases because they can, they can justify your solution.
Yeah, that's a good point, Frank. Though we started discussing this draft more with regard to home networks, but I think it's going to be useful for various other use cases, and I think we can definitely update the draft to list the ones. And I agree with you. There's a big myth that home routers do not provide any security, and like if you see some of the vendors I listed and the vendor that I work for, basically we are adding a lot of capability to the home router. We have a limited IPS on the home router. We have IoT firewall on the home router. We have basically the packet inspection enabled on the home router, and pretty much I think many of the other security vendors are doing that. And I think the dot server is not going to be a public dot server. It's going to be only for the intended dots client. So it's not going to be like it's going to receive hundreds of connections. It's just going to be one connection from the intended dots client. So this is not going to overwhelm the home router to act as any public dot server.
So if you can provide some of more evidence or more observation from your side about this possibility in the main list, I think that it can be useful for us to know. Yes, we can use this way.
Sure. I'll do
Okay,
that.
thank you. Yeah. Okay.
Hey, Maarten Aartsen, NCSCNL. So I like this. I like the point the previous speaker made with respect to the key aspect of mitigating attacks closer to the source. I would make sure that the draft includes the scenario where this begins to function as some kind of generic firewall in a user's home, because there are some countries where a net neutrality imposes quite strict restrictions on what a telecom can do, for example, or an ISP. And if this starts to function as a client-side firewall, they may receive pressure to, for example, use this for copyright or other enforcement. So I think it would be wise to kind of tailor this very strictly to the use case of DDoS, because that may have a better chance of getting deployment in such countries.
Yeah, I mean, it's a very good point. I mean, I totally agree with you on that. I mean, we don't, I mean, at least on the implementation that we didn't want to blindly take those rules and block the traffic. So what we did was we started punting all the traffic from the packet processor to the user space so that we can detect those, for example, L7 attacks that were switched. So it could be two models, right? I mean, this is pretty much specific for DDoS, and we don't want to be used for other purposes, especially for net neutrality, right? And the other case is whether we want to blindly trust what the ISP says, or do you want to do a full DPI for the flows so that you can detect and block the traffic by itself. So it's basically doing a conditional DPI for the compromised devices, and that gives us basically performance benefits that we don't inspect all the traffic flows from all the devices, but only for specific devices where the ISP seems there are bad flows happening from those devices. So that gave us good leeway for inspecting, enabling full DPI for certain devices only within the home, which could be probably 4 to 5 devices at a time launching this DDoS attack. So.
Okay, final comments on this. Okay, Tiru, thanks again for doing this presentation and the last 3 from your vacation. Much appreciated.
Hey, thanks, Roman. Thanks.
Okay, administratively, is the blue sheet somewhere in the crowd? If that can be brought up, that'd be great. So where we are on the agenda is that we have a little open mic time now to talk through what we might want to do next steps. So what we've heard so far today is most of the drafts that we currently have milestones for are on a glide slope, either for publication or about to enter working group last call. We've started talking about potential new work that we could get into. And so today you heard 2 new use cases being kind of broad and what their implications would be. And out of that conversation, it appeared that we need to talk a little bit more about what they are kind of specifically before we can move to adoption. So we're going to bring that to the mailing list. The other 2 things we talked about were 2 deferred items. One around kind of server discovery, which would be how do we in a more seamless way insert DOTS-like technology into kind of someone's network. And then the other one was around multi-homing considerations, which was providing additional guidance on how to ultimately fielding that DOTS technology. And we need to bring that back to the list to figure out whether that additional work on what we had initially laid out some milestones for is something that there's energy for to move forward. What Frank and I wanted to do kind of now is really open mic. Is there something else anyone is thinking about that they want to consider to bring forward for the working group? And I'll quote Ben here, "It's okay to be successful with just delivering what we said. that would be a great result too. Konami's coming up.
Yeah, I have one question to Pierre. So you have the server discovery and multi-homing considerations, but also you have the call home use case, which the server is in the home network. Okay, so is there any connection with the server discovery and multi-homing considerations with the call home use cases? So what about the service discovery in call home use case?
There's definitely a connection between all the three. I mean, nowadays we know that many of the home routers come with multiple interfaces and do support multi-homing, and the home router needs to initially discover the dot server. So there is an interconnectivity between all these three drafts.
Okay, thank you.
Other feedback about what we might want to start, what we might think about as next steps for the group? Going once, going twice. Okay, so I'm not hearing kind of anything more. We have the time, so if we have a little open mic time, if anyone would like to comment on anything they heard today.
So I have a question for UI on his mitigation offload use case. I'm wondering if the signaling of what the client perceives to be attack traffic and the offloading use case are actually bound tightly together, or whether they are good ideas on their own. And I haven't read the draft in detail, so this may be answered in that case. Sorry.
Yuhei, thank you for the feedback. So I will revise my draft for IETF 104, and after the revision, I want to send the mailing list. Yeah, I will.
Okay. Thank you. Other discussion we want to have?
Ben Kaluk, not really discussion, but I just wanted to apologize to everybody that the AD review on the signal channel and the data channel are taking so long. I expected to get it out sooner, and I'm sorry that I did not. I'm about 3/4 of the way through the data channel, or no, the signal channel. Sorry, I'm working on the signal channel and get to the data channel after that. So it's a little bit of a long document, but I'm making progress.
Makes sense, but we appreciate your effort in moving all that forward.
Marko Szychowski, NTSC. I apologize, I haven't been in this working group before, but I thought it might be an opportunity to raise awareness of a new proposed research group that we're launching that I think will have some overlap with what this group has been doing. It's called SMART, which stands for Stopping Malware and Researching Threats. DDoS attacks are going to be one of the threats that we're considering in that group. So it's going to be about researching ways to detect attacks on networks. And some of the people in this room might be interested in that. We're having a planning meeting this evening, 6:15 in the Pagoda Room on the 4th floor.
Thank you. Yeah.
Thanks. Tiru?
Yeah, I had one specific one, especially from the DOTS implementers. I mean, I was wondering, I mean, have you considered any auto mechanisms for provisioning the DOTS client and server for mutually authenticating each other? I know there's EST that the draft talks about, but operationally, how are you? I mean, we should probably take it to the mailing list, but I was just wondering, how do you provision for example, in our case, how do you provision the home router if it's not provided by the ISP with the right cryptographic material to trust the DOTS client in the ISP and vice versa, right? So those are some of the questions I had. I was just wondering if anybody had any insights on the provisioning mechanisms they had already deployed. That would be great to hear.
Thank you, Drew. Yeah, you can bring this on the mail list, and we hope that we have for every new guidance. Yes, we definitely we need more discussion, and if we have enough interest, I think okay, we can do this kind of work. And also for our currently today's several new individual drafts, and I think they are all make sense to some extent. I think so, but all we need is more discussion and more comments on them. So help us to improve the overall document. So yeah.
Thanks.
Hello, my name is Lawrence. I'm an IETF fellow. ISOC fellow, the IETF, first time attendee.
Welcome.
Thank you. I just want to volunteer my time to anyone who might need help. I'm fairly decent with Linux and a few scripting language, Python. So if you need help with any implementation, I'm willing to help. Thank you.
Wonderful. That'd be great. Okay, in that case, we're gonna wrap up the meeting. Again, wanted to thank Tiru for carrying the load, for some of the other presenters during his vacation for doing that, and to thank Yuhi and Tiru for bringing the 2 new use cases for our discussion. And we're going to take it to the list, and hopefully, folks can use the extra time we gave you back. Have a good morning and safe travels home.
Still have some time for talk something. Should I take this down?
Yeah, would you mind?
Okay. To the desk.
desk,
yeah. Okay. Registration desk. Okay, great.
Yeah, so I got it. Yeah, all right. Yeah, good to see you. Yeah, I would press forward. Yeah, I will. Gentle touch, because we were doing a lot of work with last call at the same time, so I push forward, but we're past that, so I'll be fast. Yeah, I don't. Nice to meet you. Yes. So.
Yeah, that's true. Those were and focus on those, which brings environment into their